Okay, now let's go to the Fluent part. Before we set up in the Fluent, we should prepare what we need. There are two meshes and one UDF code. Then we open a Fluent, select the mesh, static. Start with selected options. We may need to wait for several seconds. Then we display them here. Here is the static mesh we read inside. We also need to read in the dynamic mesh. We use the domain, zones, append case field, dynamic. Then there are something new to display. It's like this. Then before we build in the UDF code, we need to check if it's correct. First, the mass, the cylinder mass here, and the stiffness here, damping. And this ID, I'll tell you where to find this ID from the boundary condition wall cylinder. The ID of the cylinder is 3, so here should be 3. Save. Then we find from here users defined functions complied add 6DOF use built-in compare build. Okay. The console also needs some time. When we build, press the build. We build a folder called libudf here. There's no this folder before this. And when you see the done here, load. And you will see the name of the two functions. I told you to remember them here. Later I will tell you where to use these functions. And we set from start. Just follow my step. There are a lot of functions for Fluent. You don't need to understand everything. You just follow my step. If you want to learn, practice makes perfect. Here we change the time from steady to transient. Then the models change the viscous from whatever it is, but just change it into the laminar. Okay. Then the next for the materials, the deformed fluid is air. This is also what we choose the air. The density and the viscosity check if they are what you used to calculate the Reynolds number. Close. And here is the cell zone condition. The fluid in this field, the material should be air. It's all deformed. Then the boundary conditions, if we name this part into the inlet in ISIM, the Fluent knows it should be the inlet. And the only thing we need to do is that we should set the velocity of the flow into the velocity inlet. Apply, close. And the internals, outlet, they are all correct. Symmetry, wall. Yeah, here is something we need to change. The cylinder, the type of the cylinder is wall, is correct. But the type of the overset, it should be overset. Apply, close. Now it's overset. Then we need to set the overset. Create background. We give a name overset. Create, close. Then, yeah, we need to set the dynamic mesh. Here we select the 6DF, create, use users define, use rigid body here. And for the cylinder, here is the 6DF, where we load inside 6DF, create. And dynamic also need to move, but here we have to select a passive. We selected passive for all the dynamic mass zones except for the cylinder. Create or set. These should be in the dynamic mesh zone, and these three, they should be 6DF on and passive. This one, not passive. Create, close. Next, for these functions, remember to functions hooks here. Select the edit, execute at end, exe, add, OK. Then we go ahead from here. We set the lift. Select the lift force, select the cylinder, give it a name L. And we just report the plot here. We don't need to output from here because we already output with UDF code. And also the jack cost cylinder is D. Report fault. Okay. And next, then we'll change the residue from E-3 to another 30. Okay. Then we initialization for hybrid initialization, several steps. Then we will set the auth save. Here we can rough estimate the period. I remember it should be 34 seconds. Then here we can set the flow time into 1 second. That means every cycles we will save about 34 cases. Here is like 1. And data field quality. In the left column is the deformed standard qualities, which will be in the data we saved. We should add another one. Where is it? Overset cell type. Okay. Bronze. Give it a name. UR4. Okay. We should also save this case. UR4. Okay. It's telling me that the overset containing information should be in the CFF. Here, I'll tell you where to change the preference. Here, the deform is that the CFF, then the case will be saved by the format of .cas.h5. I don't like that h5, so I change from CFF to the legacy. And it's neglected that warning, means nothing. Here we already set. Then if there's anything, yeah, and here for the time step, this is our time step. Copy, paste. And the number of the time step we set to infinite. It means it will never stop unless we stop it on our own. Write keys and data. Every time just neglected this information. It means nothing. So since we have set everything, we collect the calculate. Then it will be a long journey. When we correct the calculate, there will be output 6df.txt. This is where we set the output here. 1, 2, 3, 4. 4 columns represent the current time displacement, left and false. They are all here. That means it's working now. Then the only thing we need to do is wait for several hours. And after that, I will teach you how to analyze the data and how to generate the contours and animations by TechPlot.